else print something else, right? Whoops. Like that. And then maybe it had a print done message at the end or something like that. So when we wrote this in Python, you know, we could break each one of these steps into several different steps. We could have a print statement and an input statement and a conversion, or we could just have all three of them, you know, in one swoop. Here's what it looks like when they're all in one swoop, right? Gallons equals input parentheses, or excuse me, float parentheses input parentheses, you know, gallons equals, right? Whatever the message is you want to put in there. That's how you do it in one statement. If you're going to do it in three, then you put a print galoons. I like that. Let's not spell it like that. Then, you know, or you could print, you know, hours equals, and then you could ask for the input. Hours is equal to input. And then you could do the conversion. Right. Either one works. Either one totally fine. As far as flowcharting is concerned, I don't feel like doing all those three steps if I could just do an input gallons kind of keyword. So going over to Lucidchart, pretty much we all know that they have to start with an oval. And then what you don't want to do is to stack a whole bunch of statements in a single block. Right, this one needs 2 bits of input, but we're going to put each one of those inputs into a separate block rather than combine them into one. So input output goes in that kind of shape. So this first one could be the input gallons. And then the follow-up could be the input hours. And then there are some calculations. This one only shows one calculation, but what if there were 2 calculations, right? What if y is equal to, you know, gallons divided by hours? Again, this is all just ridiculous stuff. It's just to put in the example. So then we have 2 calculations. Calculations are math statements, so we put them in a process block. There's 2 kinds of process blocks. There's the one with the bars down the side. That's a function call, a module call. We're not going to use that. Instead, we're going to use just a plain old process block. And this would be the first calculation. X is equal to gallons times hours. Or if you want to add the word set in front of it or whatever like pseudocode does, that's fine. Sure would be nice if I was drawing my little arrows, wouldn't it? And then another one coming up, which is the second calculation. Y is equal to gallons divided by hours. And then we'd have our if statement. This should have said start. Cruise on down here, an if statement. This is the part that everybody, you know, kind of rock and rolled on. Everybody knew how to write an if statement. If whatever our silly thing was supposed to be, then come over here and print yes. Print statements, of course, are an input output. So else print no. And then just have them hook back up at the bottom. And then if there was one final print statement underneath it, I don't recall if there was in the assignment, then you could have it, you know, print goodbye. Don't recall if there was one. And then a final terminator. So your flowchart should have looked a lot like this. The problems that I tended to see were combining steps, too many steps into one block, and also putting things into the wrong block shape, right? Math goes into the rectangles. Input and output goes into the quadrilaterals, so tilted rectangles. Does that make sense? So if you want, you can go ahead and redraw it even before I give you a grade on the flow chart. Just go ahead and, you know, redraw it, sneak it in. And even after I've graded it, if you feel like redrawing it, you're going to be able to do that. Hope that makes sense, guys. That help anybody? I think a couple of the people watching did make a couple of the mistakes that I showed here, specifically combining multiple statements into one block and putting the wrong shape. Now, the book will show combining multiple statements into one block, but they typically only do it for declarations. So if you have a declarations block and you feel like, you know, setting all your variables equal to 0 before you use them, oh, come on, don't erase them all. There we go. I did it again. Okay, fine. I'm not going to declare all my variables, but I'm going to declare a lot of them. Then I could have put that up here at the top if I had felt like doing it the book way, which is where you declare your variables before you use them. Right. And so there, it's okay to have a whole bunch of statements in one block. All right, so hopefully that idea will help you if you're going to redo the flow chart.
Absolutely. Thank you.
So let's go ahead and do a review of the exam. I mean, go through it together. I'll have those graded by this afternoon so everybody can get their final score. But even before then, we may as well, you know, I'll just preview it and go through it question by question, especially paying attention to the ones that I know that people had trouble with. All right. Thankfully, everybody answered true on this. I had one, you know, rascal click false on that. And I asked them why, and they said they thought it was funny. And no, everybody clicked true on that one. Thanks. All right. So this is obviously pseudocode. It's not real programming code. You know it's pseudocode because it begins with the word start and ends with the word stop. Don't even need to think about that. And so clearly this is our Python code, what we've been using every day. And so that makes this one a flow chart. All right, so a syntax error is a mistake, like a typo, or you don't tab things correctly, or you leave off a symbol or something like that. So a mistake in the grammar of the program is a syntax error. Runtime error is a program that doesn't appear until the program starts running. And that's like if it blows up in the middle of running because it tried to divide by 0, or if it tried to open a file for reading and that file name was a bad file name, right? It had a symbol that couldn't be opened or something like that. And then a logical error is a mistake in the logic of the program. That ought to be the easiest, right? Logical error, mistake in the logic. So a runtime error can look something like this. Slowly but surely, this is actually wandering towards being a functional program. It's not there yet. But I guess I could put my colons here, change the print statements, make that a, see, get back over here. Make this a comment. Print statements in this version of Python have to be surrounded by, okay, it's almost a working program. Oh, I am not used to this keyboard. There we go. All right, so now I'm going to go ahead and run it. It's probably not good yet, but it'll be there pretty soon. I don't even know what lecture we're on. We call it lecture X for now. All right, and so it's asking me, it's doing the things that I asked for. And it worked. I mean, I just typed in some silly, you know, responses, but it did work. Gallons is 6, hours is equal to 7, whatever. And it printed no for whatever purposes. But what if I give it some bad data? What if I type in 0 and 0? There, it crashed. It said float division by 0. Division by 0 is kind of an invalid operation. Some people will tell you that any number divided by 0 is infinity, but then you get into arguments about whether it's negative infinity or positive infinity. Anyways, a computer can't do that. So it crashed, right? So a runtime error is effectively a crash. It's a mistake. It's a state that the program gets into when something unexpected happens. Another one would be trying to open a file that did not exist. Not that we've done anything with file IO yet, but I could try to open this very file that I'm using right now. Let me rename it to something, yeah, like this. I'm going to say that my file name is equal to lecturex.py, and I'm going to try to open it. File equals open, parentheses, and I'm going to say, please open it for reading. So I'm going to put comma, quote, R, end quote. And now I'm going to try to read the file. So the data in the file is equal to file.read, like that. And I'm going to print the data out. And I'm going to close the file. This is all just a sneak preview of stuff that we're going to be doing in a later lecture. So I'm actually going to be reading this very file because I call this lecturex.py. That's the file that I'm trying to open. And it might actually work. I don't know if I got all the syntax correct. I hope I do. Right, and see, it opened the very file that our program is in, read it with that .read command, and it printed it, right? So we have done some file input there, but what if the file name was wrong? What if I forgot that I had a space in my file name? Then when I run it, so that's not a syntax error, right? I mean, the grammar is all correct. It's just that the things set up that the computer needed to be able to access weren't there. There was no file called lecturex.py without a space in it. So that's another example of a runtime error. Like dividing by zero, or bad input format. Like when it asked for gallons, what if I typed in something it didn't know how to handle? My gallons is 10. Is that going to work? No, that's not going to work. Yet another runtime error. Could not convert string to float. So the program just reaches a state from which it cannot recover. Now you can make it recover. You could program it so that it can avoid those things, right? We could check to make sure that hours was not equal to 0, and we could print a message rather than crash, because that's the reason why it was crashing when we typed in hours is equal to 0, because of that statement right there. So if we had an if statement, if hours equals 0, do some kind of emergency step, we could handle that way. Or we could try to open the file. We could check to see if it was there before we could open it. And there's even a way to get it to recover after a crash. Now, we haven't seen that yet, but you can recover from runtime errors with some specific language that you could add into your programs. And that's called exception handling. And I don't think it's in the book, but we'll see it anyways. I'll show it to you anyways. All right, if that was question 3, it sure has taken us a long time to answer that, didn't it? Question 5. All right, so an integer is just a whole number. A float is a number with a decimal point, and a string is something with quotes. Now, in Python in particular, integers and floats are just about interchangeable. In some languages, it's very important to know which one you're using at which particular time. But in Python, about the only time it absolutely matters is if you're manipulating lists or arrays, and you need to specify a specific value in an array. And what do I mean by that? If we have, just Google up a picture. If we have, well, there we go. This is a list of numbers, 1, 2, 4, 8, and 16. And the way you access a list is by what's known as its index number or its subscript. Just like if you have a whole, you have an apartment full of people, you have some people who live in apartment 1, some people who live in apartment 2, some people who live in apartment 3, and you have to know their apartment number. Well, their index number points to which element this is, right? This is index element 0, because computers always start counting at 0 rather than 1. This is index 1, and sometimes it's called the subscript. This is subscript 2, just like apartment 2. This is subscript 3, apartment 3, subscript 4. But anyways, these have to be whole numbers, right? You can't have apartment 1.5 unless you live in Harry Potter land and you're going to, you know, train station 3 in a quarter or whatever it is. So hope that makes sense. In some places, you have to have whole numbers, you have to have integers, but otherwise, as far as Python is concerned, they're pretty much interchangeable, which is good news for us, but we still need to at least have the idea. So a 0 or a 1 is a bit. How many bits are in a byte? 8. What's the correct order of operations? Y'all know this one. Do I have to talk name? PEMDAS, P-E-M-D-A-S. Well, it happens to be the very top one. I don't know if it's randomized for y'all or not, but happened to be the top one. Evaluate the following expression by hand. Well, the multiplication has to be done before the addition. So you would multiply 3 times 2 and get 6, and then you could do the rest of the math. The parentheses would force these to get done first, right? So 1 plus 1 becomes 2. And then exponents get done before anything else. So it would be 3 to the power of 2, which happens to be 9. Plus a 1 is 10. Here we go again, the same kind of stuff. The only difference is that we've added Boolean, which is true or false. The Python statements shown are correct or incorrect. How do we know if something is correct? This is looking bad. This question is botched. I'm going to need to fix this question because this list was supposed to be on the left side, and you could pick to see which one was, you know, correct. If we look at it, can I zoom in? You can let me zoom in, Mr. Mouse. Yeah, this is definitely a bad question. I'm going to have to give everybody full credit for it because the options over here were supposed to be on the left side and correct and incorrect are supposed to be on the right. Anyways, where do you use double equals? You use double equals for if statements. So that would be a correct one. This one would not be correct because it's not an if or a while or anything. It's just an assignment. So you would not want to do A equal 3 times 4. It would just be A is equal to 3 times 4. So that's one of the correct statements. This is another one of the correct statements. The bad statements are when you use them when you mix them up. If you use single equals on an if, that's incorrect. If you use double equals and it's not a logical expression like an if for a while, that's incorrect. Anyways, y'all are all going to get full credit on that, but if you retake it, it's going to be corrected, right? So you do need to know it. Match the following expressions with their resulting values. 5 divided by 2. Okay, these are all a pain. Forgive me if I skip these. Do I have to? Okay, let's just do like 1 or 2 of them. 5 modulus 2. 5 modulus 2. 2 goes into 5 2 times with a remainder of 1. So 1 plus 1 would be 2. And here's good old floor division. Floor division means divide and round down. So 5 divided by 2 rounded down. 2.5 rounds down to 2. Add 1 to it, and that's 3. All right, although there's a plus sign in it, it's not addition when you're dealing with strings. It's called concatenation. Fancy word, just means appending one piece of text to another. All right, so our 3 programming structures. One is repetition. What are the others?
Sequence.
Yeah, sequence. And I never remember if the book calls them decision or selection. Different books call them different things.
Selection.
So we could go with, yeah. So Joni, did you say it was selection?
I think it's
okay, good deal. Yeah, sequence, selection, and loops. And I would argue that module calls are a fourth data structure, but they don't say that, so we'd go with those. So what is sequence? It's just one after the other, like in our flow chart. What is a selection? That's an if. When you have a structure that is indented inside another structure, as shown in this flow chart, and the flow chart's missing. Gee, I guess I'll have to give credit for that one as well. Better make a note of things that I need to fix. This looked good when I previewed it, and now I'm seeing these things missing. So anyways, question 13, and then question 17 looks like it's missing its flow chart. But if you have code that looks like this, if x is equal to 0, and then you have another thing nested inside it. Whoops, I gave away the answer, nested. If y is equal to 0, print zeros, right? Whatever we were supposed to be doing there. This is called nested. Just like you have something nested inside of a bird's nest, or you have Russian nesting dolls. The flow chart would have looked something like this. Let's see if we can pop one up with a quick. Well, these are all not what I would have wanted. Here we go. This one's looking pretty good, right? So you have some kind of branch, and it's branching over, and inside that branch is another branch, right? So we have an if, and then we have an if. So that's a nested structure. I'm assuming y'all can do that one. Match the flowchart symbols to their meanings. We've just talked about that. That one's input output. Rectangles are processes, assignments, and math calculations. Diamonds are decisions, if statements. And the ovals are terminators. Okay, so which one of these is correct? We just have to kind of match. I could have tried to mess you up by putting the wrong things in the wrong shapes, right? I could have put starts inside tilted rectangles and displays inside of rectangles and stuff like that. But I didn't mess you up that way. The only thing that's changing here is the order of them. And so if we have this radius is equal to input, and then we have a calculation, and then we have an output print. So input, calculation, output. Input, calculation, output. So I would have chosen B for that. All right, so what kind of shape is this? This one's pretty easy because we can just tell that it draws 3 sides, right? And if it's got 3 sides, it's a triangle. And if you wanted the shape to be smaller, what would you do? Well, right now, these sides are of length 100. So you would just change that 100 to a smaller number. So however you worded it like that. Lower the amount of side length, edit the number 100 to lower it, pass in a different value. You know, there's lots of different ways of saying it. But that 100 definitely needed to drop in order to make it a smaller triangle.
I have a question on that one.
Uh-huh.
So we would alter the 100. Do we alter the 120?
Right. What would happen if we altered the 120s? Ooh, I wish I had a paint program. I need to have a paint program ready for us. Maybe I can fake it. Okay, so if we're cruising along and then we turn 120 degrees, it's about like that. And if we turn 120 degrees, it's about like that. But if we change that, like if we made it 90 instead,
Oh,
We'd be going like that, and then we turn 90 and we go like that. It's no longer a triangle.
okay, great. I see now.
Yeah.
So that's just your angle.
That's correct. That's correct. Because that was the dot left command. So those are the angles.
Okay, great. Thanks.
Sure. Thinking about getting rid of this question entirely, but if we're dealing in binary, you're supposed to be dealing with powers of 2, right? So that would be the answer. This is the 1's place, the 2's place, the 4's place, and the 8's place. Whereas if you're in decimal like we count on our fingers, that's the 1's place, the 10s, the 100s, and the 1000s. I think everybody knew how to do that. But anyways, it's because that's the 1's place, the 2's, and the 4's, and the 8's. So it could be as simply expressed as 8 plus 4 plus 2 plus 1. That would show why it was 15. Or if you wanted to go the long route like we did in class and say 1 times, 2 to the power of 3 plus 1 times, right? You could do it a long way too if you wanted to. Either get you the same credit, so. Like that, right? Either way is good. And some people, gave long explanations. Some people gave very short. Either way is fine. So a loop is a repetition. And this represents a loop. It's got the diamond, which makes people think it's an if statement. But a diamond with a line that goes back up and above it or back to the decision is a loop. And when I flowchart these, I actually put the word while in there and stuff like that, but the book doesn't. I like seeing the word while and the word if in these because it indicates, exactly without any thought on my brain whatsoever, I instantly know that it's a loop. But that one didn't have it there, but it is a while.
Oh, okay.
And this one, that's definitely an if. It's a single selection if, because it does either something or nothing. I'm going to go to the store or I'm going to stay home.
I have a question on that one too, on that particular one. Why, if it can go only one way, why does it have to branch off?
Well, when I say it can only go one way, it's either got something to do or nothing to do, right? If you're hungry, you're going to eat.
So it'll depend on the decision.
Right, exactly. Okay. But if I'm not hungry, I'm not going to eat. That's my null case. I'm not hungry, I'm not going to eat. But if I am hungry, I am going to eat.
Okay.
So this just doesn't have an else. So single selection if is just an if rather than an if else.
Okay.
Now here we have two alternatives, right? Mm-hmm. If I have money, I'm going to go out to eat. Not anymore, right? Else I'm going to stay home and cook a meal, right? I am doing two different things, not either something or nothing. So that's an if else. That's a dual selection if. So it's languages. The rules are the syntax of the language. What is the sentinel value? It's the value that signals the end of input. And I don't know why they threw that all the way back in chapter 1 when, loops are chapter 5, but it's the kind of thing where you say enter a test score or -1 to quit, right? Or you're reading a file and then when you get EOF from the file into file marker, then it's time to quit reading it. So that's what a sentinel value is. It's a piece of data used to signal the end of input. And it can't be a valid piece of data, right? Because if I did enter test score or 100 to quit, well, it's possible for you to make a 100 on an exam. So it wouldn't quit, right? And that's why I wouldn't make it or 0 to quit because it's possible to make a 0. But hopefully it's impossible to make a -1. So that works as a sentinel value. So languages that have an English-like, or I guess if you were in Russia, you could write a Russian programming language or whatever. But anyways, those are called high level. Low level languages are things like this. I don't know if this is going to come up with a good image or not. Yeah, we wouldn't want to program like that. all the ones and the zeros. We would not want to do something like this, where we have these cute little abbreviations and these numbers, and without the comments, we would not have a single clue as to what it was doing. Those are low-level languages. We like our nice English language versions, right? And there are lots of examples of them. One of the oldest is COBOL, you know, and it actually has English-like words. It looks a little bit, you know, more stranger, but that's just because this isn't showing any of the logic. It's not showing if statements and stuff like that. Again, it's just written with English-type words. Here we go, right? Same kind of stuff we see. If statements and display instead of print and stop commands and stuff like that. So that's just another example of a high-level programming language. This is just straight from the quizzes. The two most commonly used tools for programming are flowcharts and pseudocode. And here we go. Write a line of code, or it could be 3 lines of code, right? That asks somebody for their username. This is a message that's supposed to be displayed, and it needs to be stored in that variable. Different ways you could do it. In the one-line way, it could be username is equal to input, right? That's the one-line method. Or you could do print name and then get the input, right? Username is equal to input. Now, when I said 3 lines of code, I guess I was thinking of numeric input, right? Because our 3rd line of code would always be something like x is equal to float x, but we don't need to convert it to a number because it's a name. So it really should have only been, you know, 2 lines of input, 2 lines of code max. So either that would work or that would work. And here we go. Now we need to do all 3 steps. We need to convert it to a float. So again, it could be done in 1 line or it could be done in 3, right? Here's doing it in 1 line. Or you just print the message, ask for the input, radius is equal to input, and then convert it. Like that, or some permutation of that. I'm not going to go into the permutations, but those are the 2 different alternatives that I would have expected you to use. So a logical error, misspelling a variable name is not a logical error. That's a syntax error. Dividing by 10, definitely a logic error. If you wanted to divide by 10 when you meant to multiply. Now, what is true of modularization? Modularization is breaking your code up into functions, into modules, so that you can have big chunks of code that you can sum it up with a single word, with a single process call. Which is true. Does it facilitate reusability? Yeah, it sure does, because you can take those modules and you can put them into another program and they've already been written. They're already ready to go. That's why Python comes with a whole bunch of built-in functions like the word input and the word print and things like that, so that you would not have to write your own code that would allow the keyboard to accept input and store it into memory. It'd be insane if we had to do that each and every time. Instead, we get to use the built-in functions that Python gives us. The input word and the print word, those functions. Definitely facilitates reusability. It aids in abstraction. What is abstraction? It's just looking at it from a high level, right? You could have a function that, you know, did all the prep work, and the textbook is fond of showing a housekeeping module, right? So you could have a housekeeping module that sets everything up, and then you could have another module that reads through the loop, and then you could have one more module that, you know, finalizes the report, whatever, and allows teams of programmers to work together. That also happens to be true, right? Because you could have different groups of programmers. One programmer's working on the graphics modules and the other one's working on the database modules, and so on. This one's one of the easiest questions, right? 3 attributes a variable has. They actually have 4. But name, value, type, and memory address. Now, we don't care about memory address so much, so that's why I gave you these three. But technically, this is also an attribute of a variable because every variable needs to be pointing to a different memory address, just like every person needs their own apartment to live in, or every family needs their own apartment. You would not want to stick multiple families in the same apartment unless you're just like, really hard up for living space or something like that. So every variable points to its own memory address. In some languages, you can access things directly by memory address rather than by name, but not in this one. And so if you have a statement like this, x is equal to int input, whatever. What kind of variable is that? Well, its name is x. Its value is, well, we don't know. Whatever they typed in. Okay, let's just make it say int3, right? Its value is 3, and its type is integer. Normally, you wouldn't set it up like that. You'd just do this, right?
So when is the time when you would use the other option, or the memory address? When do
that's for programming in the C or the C++ programming language, and so it's a bit out of the scope that we're talking about right now, but it can be more efficient if you have access to the actual memory address rather than the use of variable names in order to access things directly, or to be able to modify the variable value in more than one context. And I'm not really sure how to explain it.
Oh, that's okay.
In a simple sentence.
So we won't be seeing that in Python.
Exactly. Right. And if you have the statement y is equal to 3.3, then the name of it is y. The value is 3.3, and it's not an integer anymore, it's a float. Hash represents comments. // Now, this sometimes gets people because in other programming languages, // is used for comments, but not in this one. It's floor division. ***, exponent, modulus. I'm scrolling through these pretty fast because I think that everybody, pretty much, most people got them all right. So in most modern programming languages, a variable that is declared, this is a good question. This is from the, pardon me.
Sorry, on question 40.
Yeah.
It has a multiple choice type layout.
You're right.
So you can click more than one.
Yeah, and there was no reason for it to be like that. You're right.
Yeah, I got a half point on that one because of that.
Oh, okay. Then that will certainly be corrected in the grading of it.
Okay.
Let me also make a note to that effect. Question 40 should be multiple choice. Thanks.
Yep.
Okay. So a variable or constant that is declared in a module is what? Well, it's not undefined, but let's go in and talk about modules for a moment. Say I have a function that looks like this. And it has a variable defined inside it, which means tabbed inside it. So x is equal to 3. And then it prints x. Whatever, it's a silly function. And then later on, I'm going to call test, right? This variable is called a local variable, or it's in scope. It's local to that module. Right, just like stores in Midwest City are local to us, but they're not local to people who are living in Dallas. Right, this variable is local to that module because it's inside that module. So that means that it is in scope. That's the fancy word for it. You can also have global variables. Global variables are variables that are defined outside of modules. And honestly, every variable we've used in here has pretty much been a global variable, but a global variable usually implies something a little bit different. It's just a variable that's declared above your modules, above your functions. So in this case, it is in scope, and I'd like to modify this to make it say local in parentheses, but I think that the quiz question that I drew it from, the CEngage question, just had in scope. So a global variable is one that's declared outside of modules. In scope variables, local variables are ones that are declared in modules. So question 41, I'm probably going to add some verbiage about local. So the name for ignoring non-essential details, we've already said this word, abstraction. And the flow chart. All right. Got some people answering this one. Fortunately, I didn't get anybody doing Hulk smash, I don't think. It scares me when people choose the Hulk. All right, I hope that makes sense. And why don't we go ahead and, oh, I guess we could do a little bit of chapter 5 while we're at this, but I'm almost wanting to stop here. Are there any questions that I did not already answer as to the exam? I know that you don't have, you know, not everybody has graded exams sitting in front of you, but if you do, were there any other questions that looked kind of odd to you?
No, I think it was very helpful. It cleared up some things for me.
Okay, good deal. And that's really what I want, you know. I don't care so much about exams as being measuring tools, but as learning tools. That's why I go to the effort of, you know, reviewing them and trying to give, you know, let everybody know what the correct answer would have been. In this case, that'll be to your advantage if you take it again. Mm-hmm. So we were looking at chapter 5.
Before we end this, on question 22, that's another one that has the multiple choice on it.
Okay.
So yeah, I could click both of them. So
right. Okay. 22?
Yeah.
All right. Definitely we'll fix that as well.
Would you want us to wait a little bit for you to modify it?
Yes, definitely need to wait on that.
Okay.
And yeah, let's go ahead and end it here. Seems like a good breaking point, and we can get back together on Monday and finish up loops and start on lists.
Okay. So maybe wait till tomorrow to take the test?
That would be a good idea, yes.
Okay, great.
And for the test, will we just go through the same link again to take it again?
Correct, right.
Okay.
Thank you so much. I really actually learned out of this more than I knew.
My pleasure. And yeah, we don't need to proctor it again or whatever. Just take it on your own time.
Okay.
Thanks again.
Thanks
okay.
very much.
Sure thing. See you Monday.
Okay, see you Monday.
Bye.
Are we gonna do a Zoom class on Monday?
Yes.
We are? Okay.
And if you miss a Zoom class, the video will be uploaded as well. So.
All right.
I was going to tell you, I like the YouTubes, but I really like this Zoom.
Yeah. I'd rather people have the opportunity to ask questions and stuff like that. And we turned it into a video anyway, so why not?
Yeah, it's great. Thanks.
Sure thing.
Have a good one.
You too.
Thanks.
Yeah, have a good one.